Assalamu alaikum Ali. In this video I just want to show you all the tricks that come in fluid mechanics in the first term, the midterm. So basically when he asks you to find the pressure at A, okay, in a manometer problem like this one, there's two types of pressure. There's gauge pressure and there's absolute pressure. Now, what's the difference between both of them? For example, a tire, okay, a car tire, right? The air inside here is 33 psi. That is gauge pressure. Okay, that's the pressure inside the tire or inside a certain area. Absolute pressure, that's the pressure, that's the total pressure on that tire. So what you're counting is the absolute pressure outside, the atmospheric pressure outside, which is acting on the tire, right? And the pressure inside the tire. So basically absolute is a total pressure. So it's absolute equals atmospheric pressure plus the gauge pressure, okay? And usually when he asks you here, calculate the pressure at point A, they mean the gauge by default, unless specified that he wants the absolute pressure. You're always just gonna find the gauge pressure, which is inside that area right there. That's trick number one. Trick number two, I'll try to summarize this in less than 5 minutes. Is when you're working with a manometer problem like this one, to find the unknown pressure, you need to add all the other pressures. So for example, you want to find the pressure at A, right here, okay? So that will be PA equals P1, which is this right here, atmospheric, which is 0. Now, when you go down, the pressure is positive. Why? Think of it like this. Let's say you're in a swimming pool. The lower you get in the swimming pool, the higher the pressure is. The lower you go in the swimming pool, the pressure increases and increases. So that's why when you go down, you add pressure because it's increasing, and when you go up, it's subtraction. So in the case of this mercury right here, you're going down, so it's plus P2. In terms of the height, you're only going down to this area. Why? Because the pressure here and the pressure here is the same, because it's at the same level and it's the same fluid, if that makes sense. Just like in a swimming pool, right? If you go down H, the same level, the pressure is the same anywhere in that level. If you go a little bit down, it becomes different, if that makes sense. So basically, you're going, the height for this pressure, from here to here, you're going to calculate the P, that's P2. You're not going to include this, because it's the same liquid and it's at the same level. So you don't need to worry about that. Minus P3. Now the trick is here. P pressure is force on a certain area. Force acting on a certain area. It can also be density times gravity times H. The other equation is P equals, which is right here, specific weight of the substance or the fluid times H. So basically, this equals this. Not all the time. Not all the time. I'll show you why later. But basically this, rho density times gravity equals specific weight. Now, sorry. Usually he won't give you the specific weight. That's the trick there. Sometimes he'll give it to you and sometimes he won't. But you can find it using the SG. SG equals a specific weight of the substance. SG of the substance equals specific weight of the substance divided by specific weight of water, which equals to 1. So basically you'll solve for the specific weight of the substance, which is specific weight of water times HD of the substance. So that's trick number 2, because usually we were used to solving it this way, having the density and using gravity and H, but sometimes the density won't be given, only a SG will be given, and you need to find the specific weight using this formula. Okay, so I'll make you another video. It's not that important, but these are the main tricks. For these pressures, you can use either equation, to find the pressure you can use equation 1 or equation 2. And the first trick was gauge pressure or absolute pressure. If the question does not specifically ask you to find the absolute pressure, that means he wants the gauge pressure, which is the pressure inside this area right here. But absolute pressure means the total pressure acting on this manometer, or this area right here, which is what's inside. Absolute pressure equals gauge pressure, which is the pressure inside, plus the atmospheric pressure, the pressure outside. If you have any questions, just let me know. Assalamu alaikum.